Hey everyone, welcome back to High School Python. In today's video, we're diving into arithmetic operators, the math tools of Python. Whether it's adding numbers, dividing values, or finding remainders, these operators are essential for programming. We will take a quick look at two GCSE specifications that both include a practical Python programming exam. We've also got two coding challenges for you along the way, so get ready to put your skills to the test. The Pearson Edexcel Computer Science GCSE has a 90-minute exam where students answer 6 coding questions. They also have an international GCSE specification, which has a 3-hour paper, but it is a mix of written and practical programming questions. For both specifications, all coding is done in paper too. But there is a slight difference in the arithmetic operators listed in their specifications. Both specifications have all of your basic arithmetic operators: adding, subtraction, division, and multiplication. In pretty much all coding languages, the asterisk is used for multiplication and the / for division. Both specifications include variations on division: integer division, sometimes referred to as floor division, and modulus, which returns the remainder from a division as a whole number. Finally, we will look at exponentiation, sometimes better known as power. If you're studying for the international GCSE, although Exponent is not listed in the specification, this just means you will never be asked to specifically use the exponent operator. It does not mean that you will not be asked to calculate a square or a cube value, for example. Although you can calculate these things without using exponent specifically, it will make things easier for you if you know how to use it. Okay, so let's code with some arithmetic operators. The first of our operators is addition, and we use the normal plus symbol as the operator. I have done a few calculations where we simply print 2 plus 2, which we know will be 4. 2 plus 4 is 6, and 4 plus 6 is 10. We can see these output when we run our code. We can do the same calculations with float numbers. I will add a blank line so you can see the output more clearly. When doing our calculations with the float, you'll notice that the output is also a float. The data type returned by addition is dependent on the values used in the calculation. When you initialize a variable, it is best practice to set it as the data type it is most likely to be while the program is running. We will talk more about initializing variables shortly. But for now, it is worth noting that any variables you use in your code should be declared at the start of your program and initialized with a starter value that is of a correct type for that variable's purpose. Let's do some additions with variables. You can see we have an int and a float that will be added together, with the result being stored in the answer variable. I have initialized the answer to 0, which is a whole number, so answer is an int type. But because a float is being used in the calculation, the addition operator will return a float type. Let's move on to subtraction. Subtraction uses the minus sign that you are familiar with already. Just like addition, the return type of the subtraction operator will depend on the values used in the calculation. 4 subtract 2 is 2. 2 subtract 4 is -2. And 4 minus 2.0 will give us the float value, 2.0. We can use the subtraction operator with hard-coded integer and float numbers, and with variables. The multiplication operator works just the same as addition and subtraction. The asterisk, which looks like a star, is the operator we use for multiplication. Let's have a quick look at multiplying integers and floats, both as hard-coded numbers and as variable values. And finally, we will look at division. We use the forward slash for division. Unlike the earlier arithmetic operators, dividing will always return a float type. This is simply because most divisions will not result in a whole number. Apart from this one difference, it works just the same as the other arithmetic operators. Time for your first challenge. Download the basic challenge file linked in the description below and complete the missing calculations. Pause the video now and give it a go. The solution will be revealed in a few seconds. Okay, welcome back, and well done on completing the first challenge. Now we will look at some of the more advanced arithmetic operators in Python, starting with integer division. As we have seen before, a forward slash is normal division and always results in a float type being returned. Integer division, which is sometimes called floor division, uses a double forward slash and, as the name suggests, returns an integer type. In other words, it completes a division and removes everything after the decimal point. We can see from our example here how this is just like casting a float to an integer, which we saw in the previous video. However, it can be a little different when we're working with negative values. Integer division will always round down. So when we do our calculations with a negative value being divided, a negative value, like 3.33 recurring, will round to the lower value, which is -4. And the same with our 2.5 being rounded to the number 2 with a positive integer division, but -3 when doing the negative integer division. Let's take a look at modulus, also known as modulo, which uses the percentage symbol. This is a bit like the math you did when you were in early years of school, before you learned about decimal values. When your teacher first taught you about division, you divided the number into whole number groups and included how many were left over or the remainder that could not make a full group. That remainder is modulus. It is just the remainder left over when you do one of these integer-only type divisions. 9 divided by 3 is 3 with 0 left over. 17 divided by 3 is 5 with 2 left over. And finally, 5 divided by 2 is 2 with a remainder of 1. When we run our code, you will see that modulus returns this remainder value. A common purpose of modulus is to check if a number is divisible by another number. In a high school practical Python exam, you might see it used to check for even numbers, as the example on the screen now. Or in a program based on prime numbers. We may even create a program just like this in a later video. For now, I'm going to combine integer division and modulus to create a program that will allow users to input two numbers, and we will calculate the child and remainder values and print those back to the shell. As you can see, I have initialized my variables at the start of the program. This is something you should start doing in all of your code. I have used the input and int functions to get my dividend, the number that will be divided, and a divisor, the number will be divided by. I then need two calculations. The first is floor division to get my child, and then modulus to calculate the remainder. Notice how I combine my two variables and a string when printing my output to the shell. You will use all of these same skills now, because it is time for your second challenge. Your task is to ask the user to enter a number of minutes. Use integer division and modulus to convert the given number of minutes into weeks, days, hours, and minutes, and display the results clearly in the shell. Download the file using the link in the description and complete the program. Pause this video while you do that. The solution will be shown in a few seconds. To convert my minutes into hours, I use integer division with the number 60, and modulus will give me the remaining minutes. Now that I know my total number of hours, we can use integer division and modulus with the number 24 to work out how many full days and how many hours left over. And then the same thing to turn days into weeks. If your solution looks like this, well done, you will have scored most of the marks. You may have noticed that the 60, 24, and 7 were already stored as variables at the top of our program, though you may have wondered why they were all in uppercase. Uppercase represents a constant. These are like variables, but constants are not supposed to change at any point in our code. There will always be 60 minutes in an hour. There will always be 24 hours in a day. If you were given constants like this in a coding file during an exam, you should always use these constants. I regularly see students create their own variables, which are duplicates of these given constants. Or, like our code here, they just hard code the numbers. But to get full marks in a question like this, you should have used the given constants. The functionality won't change. The code would still work fine. But using the constants makes the code easier for humans to understand, and is just good practice. From this point on, if you're given constants in any code files, including in class from your teacher, you should use them in your code. Get into good habits early, and they will make a big difference to your final grade. On to our final arithmetic operator, exponentiation, or the exponent, also known as to the power of. Common exponents are squared, a number to the power of 2, or a number multiplied by itself. I am sure you are familiar with this concept already. Also cubed, a number to the power of 3, or a number multiplied by itself, and then multiplied by itself again. We can raise a number to the power of any number. You can see the power is just how many times that number is multiplied. But things can get a little messy when the power becomes larger. When I try to raise 2 to the power of 10 and run my code, I get the wrong output. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. When the exponent gets too big, it is easy to make errors this way. To get an exponent, we use a double asterisk symbol. So a number squared would be written as the number followed by the double asterisk and then 2. Cube would be the number followed by the double asterisk and then 3, and so on. Functionally, exponent would give the same result as the repeated multiplication shown above. But they are easier to understand when a human sees the code, and you are less likely to make errors with larger exponents. Today we looked at the arithmetic operators built into Python. Basic operators such as add, subtract, multiply, and divide. Then more advanced operators, integer division and modulus, as well as calculating exponents. We saw currently the only two GCSE specifications that include a practical programming exam. And although the International GCSE does not specify exponent, it is better to know it as it can still be used in your exam answers. You completed 2 coding challenges this time. The first using some basic arithmetic operators, and the second using advanced division to calculate weeks, days, and hours from a given number of minutes. If you're studying for GCSE computer science or another programming qualification, make sure to subscribe and like this video. I'll be making tons of Python videos packed with exam tips to help you succeed. Got questions? Drop them in the comments, and I'll do my best to help. Thanks for watching, and see you in the next video.